button. There it goes. Let me turn on sharing before I go anywhere. Hey, it's Coffee Compiler Club. Here today to talk about compilers and getting your monads in a bind, or modules or not the modules, and what's readable and what's not. Uh, that's it. I think we're going to open with something to do with modules and readability. And Levo, you were going to say something.
I kind of don't, but I prefer having modules over more readable code because with modules you don't have spaghetti, and readable code is all good, but if it's spaghetti, it's harder to deal with.
I guess I would claim that modules is part of being more readable, and you can get spaghetti code in anything in any place.
Yes, but if you only have time to do one, or if you have to mandate one of them.
Yeah,
If
I'm not
you,
sure I understand this trade-off. Like, can you give me examples? Like, because I thought modules are like one way to, yeah, get readable code, or like maybe an example would be nice, or you could maybe share some code.
Well, with a readable code, I just mean how you name things, having a consistent naming style. Um, just I mostly think of naming when people say readable,
Well,
and
I
not
think
having too much cleverness.
readability stretches far more than naming. And
yeah, a lot of places go there or not. I don't know if I want to go there. Coding styles is
Yeah.
sensitive for everybody.
I usually think of that trade-off as being a very strict large interface versus a very lenient small interface. If I have a module and I import a function and all I know is I give it a string and it gives me back some particular struct, and I know the shape of the struct and I know I gave it a string, like that could be doing anything behind the hood. I don't know if this is going to take a nanosecond or if this is going to take a minute and a half.
Right. The big
Whereas if I
SQL
have
query.
a struct there and I access a field and I know what's going on, that field access is much less flexible than the function call to an interface that's defined in a module that's imported somewhere. And I could rely on that to get a lot of benefits from the fact that I'm relying on the fact that I know a lot about the implementation. But now, if the implementation changes, I've become fragile. So there's always this question of, do I want to have really tiny interfaces that give me flexibility as a programmer, or do I want to have a really rigid, well-defined interface that gives me a lot I can rely on as a programmer?
That goes back to the oops versus no oops discussion that was on the channel, I think, yesterday. I was not involved in it, so I don't remember the details, but that just reminds me of that.
But I'm still not understanding where the trade-off is. Like, because why would having modules like require sacrificing readability? Like, are you saying that one is maybe like, for instance, I would understand if you said something like, I would say modules are more useful or give more benefit than
you have
relying on
two axes
readability.
here, Adrian. You have the axis of put everything into one pile of spaghetti, or put spaghetti into small compartments called modules. That's one axis. The other axis is make your code readable versus make your code unreadable, right? So you have four quadrants. You have unreadable single pile of spaghetti. We've all worked on those apps. They suck ass. There's unreadable, but in modules, so you can close the door and pretend there's no mess in there, which still sucks ass. But as long as you never have to go in the room, what Levo's saying is he really likes that. Don't go in the room.
Yeah.
It sucks ass if you have to go in there, but that's a technical term, by the way.
Just shows that you've raised teenagers.
Right. And then the other quadrant is one big pile of spaghetti, but it's beautiful code. It's really not that great either, but it's like, so the last two we've discussed are kind of defensible compared to the first one. And then the fourth quadrant, of course, is Nirvana, where everything's beautiful and it's nicely compartmentalized.
And there are rainbows and unicorns everywhere.
Rainbows and unicorns everywhere.
Yeah,
Okay,
so I wasn't.
get it.
So Adrian, I wasn't trying to say there's a trade-off. I was just because what happened in a couple of my other jobs was I was put on a task, and things were not in modules, and I had to touch code that no one in the room understood. And having it readable didn't help me because I had no idea what the domain was all about. Like I would just had to change like a thing or two, and it was just
Well, there's
weird because I had
readability
to
at
understand so much. But if it
readability
was in a
at
module, there's less to understand.
there's readability at scales where the code is well spaced and well commented and well indented and nice, beautiful names that are easy to read. And it implements some horrific algorithm that no one knows what the fuck it's doing. And you know, you can get a lot of these algorithms out of academia. Tarjan's famous for them. They're really simple, they're really short, sweet, pretty, and you have no fucking clue what's going on in them. So yeah, you could have pretty looking code that is still completely I don't even call it not unmanageable, ununderstandable because it just goes deep too quick.
Yeah, and scale matters. So to use the example of LLVM versus C2,
Yeah.
the people I've talked to who are like, in LLVM, you can get in there and make a small change because you're trying to run some little experiment and just not understand what's going on in 99% of LLVM. Whereas the people I've talked to with C2 are like, I didn't get it, and 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 then I got it, and now I understand the whole thing top to bottom, and it seems like such an obviously better thing to do than all of the stuff going on in LLVM. And it's like, right, but it's sort of
need a bigger,
your understanding has this step function in
has
it.
a step function in it. That's interesting. Okay.
Sounds like a
I
functional
don't know if you've
problem.
had the same experience teaching people how to be productive in C2.
I walked away because, you know, Sun and Oracle like chased me off hard. You know, I got beaten with the lawsuit stick a few times, so I ran away and stayed away. So, you know, I didn't teach money people directly. I went on stage a bunch. I showed people, but that's not.
Yeah, I mean, C2 for a lot of practical purposes was Cliff. There was no team working on that code. They had 15 other people, but all combined, they understood only 5% of the code base and contributed only 1% of the code.
Yeah.
So when Cliff left, you know, he was cursed for a long time because people just couldn't understand what he was doing. And that's not just because Cliff uses Cliff normal form, CNF he calls it for his code style.
Yes, Cliff normal form. Everyone should adopt it.
But it's mainly because, you know, he was doing things that no one had ever done before. And
That's true.
he was doing them in a style that he was comfortable with. And, you know, he didn't.
And then I got told by lots of people that I should change how I do it and how I write it. And I should change my tools and I should change my style. And I should change this and change that. And I would look and say, but you're not doing the things I'm doing. You can't do the things I'm doing. And half the shit you're telling me to do would stop me from doing the things I'm doing. It's completely counterproductive. So then I would get, this is one of my red hot buttons here. I would get told, you know, you
have to use industry standard tools if you want to get industry standard results.
Exactly. Thank you very much.
Yeah, I believe that it's pretty detrimental. So telling someone to do your way, that's completely not unacceptable. So if you want to do it. Let him do his job and see what's come up.
You know, this is, I wish Dibiendu was here. This sort of goes to the heart of the conflict that Dibiendu and I end up hitting all the time, which is he has some industry standard thing he's trying to do, and I'm just not the industry standard guy and have been hard taught, you know, beaten, deep emotional scarring to not do industry standard things because they don't work, or at least for everything I do. And the people who promote them have no justification for their promotions. It's just best practices, but they can't describe why it's best practices. And I'm just like, okay, nice, but you know, you're not doing what I'm doing. So what the hell are you trying to tell me what best means? Fine, I should quit now.
The way to get me very irritated or angry is to tell me how to write my code.
So by the way, Rust is one of the most amazing languages I've gotten to code in this week. That language is just
nice try, Cameron.
gorgeous.
You don't understand Rust.
Fine.
If only someone else could build a compiler half as fast as Rust.
There's two scenarios that I find I have trouble telling the difference between. One of them is, here is a totally arbitrary thing that the industry has decided to standardize on, but is really useful if we all agree. I think we should either all drive on the left side of the road or all drive on the right side of the road, but we shouldn't each pick our own personal preference. Even though it's totally arbitrary, there's real value in the alignment itself.
Yes, right. Okay.
And
That's
then
a
there's
very good
things that are
point.
just like total tradition. This is a hat-wearing society. This is a not hat-wearing society. Like,
When in
the fact that
Rome,
we've all aligned on it doesn't seem to really make any difference either way. And I can't always tell the difference between this is the best practice that's everybody's doing because there's value in having a societal alignment, and this is the best practice that everyone's doing because no one's really thinking about it and everyone's just copying everyone else.
Static
it's also
globals
worth-
are all uppercase.
It's also worth pointing out that there are some absolutes. Like, it's really hard because we wish everything were like, Boolean, like this sucks versus this is awesome, right? But I have to tell you, like, there are people whose code I've looked at and I'm like, this is art. It's seriously art. Like, I learned so much just by reading it, right? So I'll give you one example from back in the day, back when Cliff was still at Sun. When Josh Block first released the collections APIs,
Yeah.
I learned so much. Not like I didn't learn any new keywords, I didn't learn any new expressions, I didn't learn any new facts, right? But I learned so much about how to think about certain problems by reading that code. It was beautiful. It really was.
Yeah, you did a
Now,
good job.
looking back, I see all sorts of problems with it. 25 years later, I'm so much smarter, right? But the amount the amount that I learned from it was shocking in terms of hours invested versus things it made me think about, realize, and understand. It was so nice.
I still wonder sometimes about why my code looks like a compiler output, as you said.
Like a compiler output?
Same reason Cliff's does.
Yeah, maybe.
Because you're thinking, you already absorb several layers of translation before you start typing. You've already pre-processed your code pretty significantly. That's why Cliff, every time Cliff has to make a minor change to something in the Ecstasy's work he's doing, he's like, okay, I just had to rewrite 45 files. And it's like, and I get it. I totally understand. Like, I'm not criticizing.
Well, that's a work in progress that's still pretty
Exactly.
pretty gnarly at the moment. Yeah.
I'm
So-
not criticizing the style.
One of the
I'm
things
saying that when you pre-process stuff, one of the things that it means is that small changes have big ripple.
Yeah, but I don't know that I couldn't tell you what API I would have done that would have not caused that to happen because I
Understood.
didn't know what I didn't know until I got in and got dirty.
It's an
Right.
observation, not a criticism.
Yeah. Right. Well, no, it's worth thinking about. So there's this other thing I was going to say. One of the things that goes on in my head is I collapse these layers
Mhm.
so that the raw underlying data structure is simultaneously an array, it's simultaneously a list of unique things, it's simultaneously an access for whatever, it's simultaneously the program IR graph, it's simultaneously, and it's all these things all at once.
Yeah.
And there's not a separate pieces to them. So it doesn't make sense to wrap it and put a giant ass API that has a huge count of functions and fields and whatever, when it's just a fucking array that is also, and is also, and is also. And then I see that seems to bug some set of people. Your keyboard brings the camera on you. What did I do there? Levo, what?
No, Yasser's keyboard is bringing the focus to him. So I see him instead of whoever's speaking.
Oh, I'm not typing, but I'll mute.
Oh, you must have backup, but you have a headset. How do your mic's not? But that's fine. Okay. Okay. Are we
Levo, you on your
doing more
phone
here?
or something?
Sorry, go ahead.
Levo, are you zooming on your phone?
Oh, that happy, but I also want to bring up the other to make me irritated. I didn't realize having bright white flashes on your eye when you try to program. That was such an irritating thing, and I'm surprised no one else was bothered by that, because even in the middle of the day, it bothers me.
So when I was 20, my night vision would kick in within a fraction of a second, hugely fast. I could flip the lights off in a closed boxed room and read by the light creeping under the door. I could walk out into a fully clouded midnight no moon and walk freely through the woods. It was just instantaneous. And now I take many minutes to get any kind of night vision at all, to 20 minutes or something. And my ability to detect contrast has fallen off by 50% or more. You know, part of the, you know, the laser spot welding on my eye was I lost a lot of visual acuity. And so I need high contrast fonts, and I need light background and dark lettering, like I'm reading a book. And I'm not saying this is right or wrong, or can or can't stand. I'm saying as I've aged, I need help. And one of them is I like my light background, and I like my high contrast and slightly bigger fonts. So this too may change for you, sir. Enjoy it while you can.
That every single person on who like commented did not see the problem with Windows slashing that brightness every time I try to open
You
window.
had a different problem because like somewhere in there you had so many things going on for the processor to try to catch up. Like your Windows is so far out of date and so much trying to catch up that every simple thing, like I used Windows 6, 7, 8, 9 on older machines of the era you're looking at, and they were never super bad like you're getting.
Did you try 11?
Well, no, I'm not using 11 now because it doesn't offer me anything.
It's 11.
I'm on an older, well, I imagine it would be as normally fast as my 10 is after I get done yanking the bloatware.
Well, not just the bloatware, Levo also is running on a spinning hard drive, and Windows
Yeah,
11.
I heard that.
Windows 11 cannot run on anything but NVMe. So
I have an SSD for my OS, and I have a spinning drive because it was almost free for my games, and they take a little while to load, and I don't care.
So 10 millisecond access time on a spinning disk is not unreasonable, but 10 milliseconds, if that 10 milliseconds occurs while the screen is bitblitted to white, like
you'll see it. Yep.
You'll see it because the frame buffer will flush.
Go get an SSD drive for your Windows 11.
It's also probably like weird to have. So this is something I think I've ran into actually with Windows, which is that you probably should set your backgrounds on the window itself to black, because if you don't like successfully render a frame after resize, it will just white, and it's like just a stupid thing.
Yeah, you gotta tell me how to do that because I couldn't find that.
It's like a code thing. I don't know if there's like a setting for it.
Wait, set your background to black?
Yeah, so like I'm talking about like Windows APIs wise, not like I don't know if there's a Visual Studio code setting for it.
Yes,
there's a default WinProc for what happens when it has to repaint the window, and the first thing it does is it blasts out white pixels everywhere. So all you have to do is intercept that. Like we're talking about 1980s switch programming for wild get message, translate message, dispatch message loops in Windows. We're talking about, it's a antique.
Yeah, it's weird because Windows has got this whole like thing about backwards compatibility. So like that's still like not the worst way to program Windows on Windows, I guess.
I also keep changing the frameworks, but I don't program to the Windows API. I'm unusual in many ways. Fine.
Yeah.
But Windows runs Linux okay now.
Yeah, my solution right now is just use Linux, and if I have to do something on Windows, I try to do it on the command line so I don't have to open up any windows.
I would have to. I've thought about the Linux Windows WSL.
We call that DOS, by the way.
No, I'm not talking about.
Yes, DOS is an improvement over 11.
Okay, fine.
Sorry, Cliff, I was responding to Levo. He uses Windows for the command line.
Oh God. DOS. No, don't use Windows for the command line. Yeah, how many different command lines on Windows do I have at any given moment? There's like
I honestly thought my VM was just like busted and being slow. I did not realize that 11 was just that slow.
No,
like, I honestly thought it was a VM.
Yeah, it is kind of amazing to me that no language has really taken over for Bash as the best way to do interactive computing.
Yeah.
I sort of expected at some
Yeah.
point someone was going to come along with their own command line that was like, I want to list files and move things and navigate the computer and launch processes. And
Data
What do you think about JavaScript?
Data scientists will commonly use Python or R. And they will go as like in replacement for Bash, but they're generally also pretty Bash savvy.
Yeah. I mean, I did know people used to do that with MATLAB. That
okay, yeah,
even just moving files around the computer, I knew some engineers who just lived in the MATLAB.
Right. So I met plenty of guys not doing MATLAB, but they knew of or whatever. But right, the crowd I hung out with doing data science stuff was all doing Python R.
I know some people use Python for scripting on the like a command line, and I know some people try to do JavaScript as a shell.
And simple syntax can go a long way. One of the reasons MATLAB was popular with these guys was they could write a for loop and have in the body of the for loop bang space and then some line of shell command and it would run.
Perl by any other name.
You know, the fact that calling out to the command line was just put an exclamation point space as the first non-white space characters on your line.
And then that's a good hint. I'll keep that in mind.
Yeah, that sounds very convenient.
Something
how do you
to get.
I've been going back through the back catalog of ArrayCast, listening to them talk about the array programming languages and APL and BQN.
Let's say you're talking APL now. Yes.
And they do make a lot of points of if you can get really terse syntax for things.
Yeah.
You look at these programs that are 24 characters long.
Yeah.
And I'm like, I have no idea what this is. I'm going to take it over to ChatGPT and be like, can you explain this code to me? And it prints out the 6 pages of Python code that are the equivalent with lots of comments explaining what's going on.
That may be
and then you look at it and you're like, oh, that's really clever. And I have been able to get benefit from understanding the array programming way of doing things by taking people's advent of code APL examples that I can't read at all because I don't even know what the glyphs mean, dropping them in some large language model and saying, hey, can you
I spent a
explain what
semester
this means?
Coding in APL just to have fun and learn how to code APL. And the answer was I had my 24 character line that would do an in-body simulation. And what the hell, how are you going to read it? I don't know. And then print it out too on a screen, had green screen. I had an in-body simulation going with shit moving around in some very short count characters.
It's very funny to me when I'm going into the back catalog and listening from like the first episode years ago, and they're all lamenting the fact that the thing that APL is really good at is processing tensors, but nobody cares about streaming, flowing tensor processing systems anymore. So this language is in trouble. And if only the world would move back to really caring about tensors flowing, then it would be the new age of APL. And I'm like,
It comes around, goes around, or what's old is new again? What's new is old again?
This past week, I've been using ChatGPT as a document generator, hallucinator. It generates such good documentation, even if it's wrong. It's so good because I can look up the correct features on MSDN, and then just use what the documentation says how I should use it as the correct way to use it. Like, it doesn't matter if parameters are switched around or if you get a little thing wrong. I have an idea of how to use it, and I could look up the function names. It's so good. I did that for all my Windows programming. It was so handy.
All right. Someday I'll find a good use for ChatGPT. It sounds like it's actually getting to the point where maybe
I was playing with the new Gemini upload PDFs feature. So naturally, I uploaded the Hacker's Delight PDF to it and started being like, please give me the paragraph from this book that explains to me how to clear the middle 3 bits of an int. And it does. Like, those answers are in that book, but they're not super easy to find. So if you tell Gemini, please answer with a quote from Hacker's Delight. Okay, here's my question. You get really high quality answers.
Interesting. Okay. It's getting there then. Yeah. Maybe in my lifetime, I'll find
it's not there, but it's getting there.
All right. What else?
I was impressed with its ability to explain APL code, though.
And this week we saw mild-mannered Yasser. Not so mild-mannered. He grins.
I feel like I've gotten into the pattern too many times, and I feel like I should say something. Because I guess to describe the pattern, it kind of goes like, I will get into some argument, and then at the end, Cliff will say, oh, Yazzer's correct, and then like, because he's Cliff, they're not going to argue with him in the same way that they might argue with me. And so, you know, I'm just left with like, oh, I can be told, oh, you're young, because yeah, I'm 20. And so, but like, you can't say, oh, Cliff's young.
Young at heart. I'm young at heart.
I mean, you
That's
can
Cliff's
say Cliff
problem.
is wrong,
Not enough
right?
years of programming.
I do disagree with Cliff on something. We could talk about it right now if Cliff feels like it.
I
But
promise I won't kill you.
Pardon?
He says he promises he won't kill you, Leva.
Okay. So a couple months ago, you said that WASM can be optimized as well as JavaScript, or at least you said you don't see why it can't. I see plenty of reasons why it can't.
Okay, I don't recall saying that comment. You better find the quote on that one.
I actually remember him saying sort of the opposite. I think I was on the side that WASM can be optimized. And so
WASM drops even more facts than JavaScript does that are very useful for optimization. I don't think
absolutely, but like the reason why I think that it's still possible to optimize is because C drops just as many facts. Like for instance, aliasing. C doesn't transmit so much aliasing information, and it's super annoying. But also, if C can get away with it, I'd imagine you could get near the performance of C with WASM.
C takes one other shortcut that WASM does not, which is C is okay with crash and burn.
Yeah, but
Undefined
WASM
behavior says launch the missiles, explode the world. It's all fine.
WASM has types, and JavaScript has infinite flexibility on every reference. So you're fucked if you're trying to optimize JavaScript. Like, you know, Google has put $17 trillion into it, and it still takes a massive, you know, look at the heap size usage on JavaScript. You know, it's amazing performance. Like, I can't believe they did as well as they did, but it's still a disaster. And
So
WASM is basically just a simple register machine with, you know, well.
Yeah, it's assembly language on a register machine locked inside a sandbox. But when you get down to the register machine, you lost so much shit. All right, so Leva, yeah.
Cliff, were you saying that WASM can't be optimized as well as Java, or it can be optimized as well?
Break out Java from JavaScript. A second ago, you said JavaScript.
Oh, I thought I said Java.
Java has strong types that allow for a lot of optimization. JavaScript drops a lot of the strong typing and also has a worse numerical model, which you get back by a huge amount of aggressive engineering around specialization, which brings you within 30% of Java running if everyone's optimized well and no one's, you know, being a slum bag. WASM drops more shit, and as Yasser point is, it's still got as much shit going on as C does, but WASM requires no crashing outside the sandbox, and C, of course, says, ha, all bets are off, die like a pig. So I claim...
But my understanding with WASM was you were supposed to be doing most of the compiling before you got to WASM.
Before you got there, yeah, right. WASM's an alternative assembly backend, which I think is a fine solution for it, especially if there's some way you could tell the WASM engine that I know that the bounds check on this array reference is good, don't bother to bounds check, except that WASM has to assume you're a cheaty bastard trying to break him. So there's no security you can hand him. There's no proof you can hand him that says this array is safe.
Oh, so actually, this is the other bit of it, which is this is an issue with WASM 64, but a good thing for WASM 32, which is that with WASM 32 stuff, you could just like allocate 4 gigabytes of like virtual like memory, and then just say we're inside the sandbox. And what WASM guarantees is actually technically what WASM is guaranteeing on, I think the allocation granularity is something like 64 kilobytes, so that it can work nicely with Windows's weird rules around the MMUs. But essentially, you could just like say I'm in this box, and then the bounds checking is all done by the MMU,
by the box,
and then and in which case I'd imagine you could get yourself probably around 90% of the performance, because you wouldn't have to write the bounds checks yourself. And then the leftover checks would be things like it's going to need some like sanity checks on like control flow, like dynamic control flow, because the jump table bits. But other than that, I'd imagine it would be
if you
comparable.
put yourself
Sometimes catching the seg fault is cheaper than checking the bounds.
Yeah. Oh yeah, absolutely.
Yep.
Yeah, the MMU does it on every clock cycle for free. You paid when you bought the silicon, but not when you run it.
Yeah, especially because WASM isn't like built for exceptions, really. So like the crash is just we died and it's over now.
This is like me programming on IBM mainframes, you know, in the 70s. You got an A bend, you got a core dump. Go reverse engineer the core dump, figure out why you crashed.
Yeah.
Okay, fine.
You know,
it's one of the big things I want to improve on with my WASM runtime, because the WASM 3 is an interpreter, but for some reason it doesn't have like step debugging functionality. So one of the first things I ended up with in my WASM runtime, which by the way is like JITted all the way, as in like there's a template JIT and then there's like the normal my optimizing JIT. That one actually does have step debugging, because it is really annoying to. For me, the good WASM experience is actually that you emit like a sort of readable WASM so that it's debuggable. And then you have the JIT optimize things behind the scenes, and that way you can have like the debuggable experience while still running like C code, for instance, in a sandbox.
This is what Java does. It's absolutely the way to go. Yeah.
So Yasser, have you worked on development teams, and if so, how big? I'm just curious.
I think probably the biggest team I've worked on is maybe like 5 people.
And was that academic or?
No, it was work related. I work at this company called Whitebox, and we work on a sort of tracing debugger. The idea is that you record the state of the program and then you basically visualize that.
Cool. Very cool.
It's less fun when your team is 40 people.
Yeah, I'd imagine.
When it gets to a couple thousand, it gets really interesting.
Well, so that's one of the big things I definitely noticed.
I think that's why Java became so popular. It was the first language that really did a 4,000 person team in any kind of sane way.
I don't think I want 4,000 people in a team, though. That's something I realized, which is that, like yesterday when Cameron and I were speaking, at the core of our disagreement, it's that I'm like, we're optimizing around sort of, or like we're sort of valuing different like groups of people. I'm sort of okay with saying like, you know, this person is stupid, and like I'm okay with them not being able to use my code well, or like not being able to adapt it. Well, Cameron might not be able to say that because like economics wise, it probably doesn't work out to just like say that. I'm sort of tanking the inefficiency of saying I only want smart people.
No. Well, I'll claim that that's a good answer, or at least for me.
I value that. Yeah.
If I have to code pair work with people who aren't like really fucking sharp, it's just slower than just me going.
Put up with me, okay?
I'll claim that you're funny and you're humble and you're whatever, but you know you're pretty fucking bright, sir.
It's fine. Cameron's behind an abstraction.
I'm a lot slower than I used to be mentally. It's shocking. Like Yasser, I was running a development organization when I was 19, and I felt like king of the world, and I still felt that way at 30, and by 40 I was like, I can't add 2 and 2 anymore.
I'm gonna blame.
So I found here that driving is actually a pretty good analogy for programming. That if you look at the 17-year-olds who are driving, they have vastly superior reflexes, reaction times, can get themselves out of near accidents with much higher rates. If you put them in simulators that force you into dangerous circumstances and you just have to get out of it, they come up with a instantaneous creative solution to get themselves out of danger with much higher rates than a 60-year-old. However, they have much higher rates of being injured in car crashes, because the way that the 60-year-old gets out of the car crash is they notice that these 2 cars way down the road are a little too close to each other, and that means they're behaving a little bit erratically. So they just slow down and create a space. So when one of them does something stupid, there's a space for the other one to go into.
I have an extremely well-refined sense of what goes
an
on.
Older senior programmer can't do the, I stayed up all night with a case of Surge and rewrote the whole system. But they are much better at avoiding the circumstance where the best answer is to just rewrite the whole subsystem.
Well, this is why
Mountain Dew, but yeah.
This is why earlier I said that I don't like it when people tell me how to write my code, because I know how to write something in a way that it doesn't matter how complicated it gets. It's changing one thing is not going to make anything else crash and burn. And it's going to be pretty efficient the way I do it, even though it's not what other people do or how they've been taught. But I get people telling me like I shouldn't use global variables, and I just get annoyed because the way I use global variables is very useful, and I don't want anyone taking that away or just being annoying when they don't know how to use it.
So the recent discussion about global variables in the simple project focused around the one use of a global variable that I wanted a function local static, which Java does not provide. So I put the function local static as a static next to the function. And then I got it's a global variable shed, but it's only used by the function in the function when the function runs. And when you're out of the function,
So static in the C sense of the term. So I'd call that a function local property or a function local field.
Right. The other languages have support for this. So there is this notion of
you can't just define the function inside of some kind of closure to begin with.
No, it's Java.
So the function closes over the variable.
Right. It's Java.
You can't close over a mutable in Java.
Yeah.
Oh, it requires
Java lambdas don't close over a mutable?
They don't close over mutable values. They have to be effectively final.
Effectively final. Yeah.
Yeah.
Ah, today I learned.
Yeah.
But I'm on the completely different spectrum. I don't use global variables at all, but maybe all cost, even if if it hurts me. I don't
use. By
use
the way, Aaron, the reason that the Go choked on, and by the way, we made the same exact mistake in Ecstasy that the Go compiler did with the closing over mutable variables. The for loop example. Do you know the one I'm talking about? I'll post a link. I'll find a link and post it. We talked about it once before here, but
yeah.
I mean, Python was famous for the fact that you used to be like 1 to 10 lambda this thing, close over it, and then when you're done, it's like printing 10, 10, 10, 10, 10, 10, 10, 10, 10.
Right.
Like,
that's what Go did as well. Except Go, I think, was 1, 1, 1, 1, 1. But yeah.
Why don't you detect that you are capturing a global variable and put it inside something that can be updated? So essentially turn it into a monad or something that can be captured the state by state. We can ask for the next state
that's what Diviende was doing. He put it inside a class with accessors, I guess.
Yeah, right. Well, that's the other one, is a different one, which is the global int counter for nodes, which has this other property. And the solution he proposes in my eye and head has twice as much syntax and overhead and complexity than just having a fucking dumb counter. But to understand the two sides of it, you have to look at both of them, and we'd have to pull a code up. People can talk about it. We went around that one. You guys want to go after it?
Yeah, why not?
Okay.
Well, I can give a short summary of how I use global variables if you guys want to hear that.
Yeah,
it's very short. So essentially, when I'm building my AST, I will, instead of passing a state to every single function, and there's literally hundreds of functions, I just have it as a static thread local global variable. And that's weird to say, but yeah, it's a static underscore thread, and then int or pointer or whatever. And then in my actual code, like instead of just passing the like an extra struct everywhere, that makes no sense. It's effectively global. So within global state, and then every time I change it, I put a copy of the pointer or the integer onto the stack. I change it, and then like I have a macro that restores the original value. So if I call functions recursively, like I'm trying to figure out. Well, actually, I don't want to give an example because I can't remember. It's been like months, but yeah.
I do have examples of when I do use globals. One of them being like, I think I wrote the quick parser. Oh,
I restore the original value, so it doesn't look like I'm using global variables. I am using global, but it doesn't look like it because everything gets restored all the time.
You have a stack, is what I heard you just say. It's a parallel execution stack to the normal one where you stack your globals and unstack your globals. Is that?
Yeah, I only touch those globals once in a while. Like if I'm processing a different function, I'll push that out.
Well, you also
Oh.
said it was thread local, so it's not a global.
Yeah. Right.
That's well, it's global as in it's outside of a function.
Yeah.
No, it's global as in your code refers to
it's
it by
globally
its
It's
name.
a thread global. It's a thread global.
Yeah. Yeah. You have access to a value that is not being passed as an argument. And in your case, you're also stacking it. There's the example for Python.
And the name doesn't have to be qualified. That's what global
yeah.
means, is you're using a name that does not have to be qualified. That's your meaning of the term global.
So, so to break it down here, there's a static global that's actually global. There's a static global that is restricted in scope, like a function static. There's either of those taken as a thread local. And then Levo has another version which says, on top of that, I'll stack it like it's a stack function, but I don't have to pass it as an argument. It's just available to me as an unqualified name. Which actually, that's a version I hadn't seen before. The other three I'd seen.
Oh, I use that all the time.
No, it sounds interesting.
Well, for my compiler at least.
Yeah, it sounds interesting. So in the first case, whatever your global is, it's sort of relatively easy to flip it to stack local to thread local, and then it becomes thread local, obviously, and that solves a bunch of problems when you have to go from one to many for things. And compilers are interested in single threads. When you want to have two compiler threads, moving your globals to thread locals fixes it that way. And then you get the benefits of not having to have a name, an argument being passed in and out of every function. You have an unqualified name you can go grab, and also be multi-threaded.
I ended up with like a similar design, except I originally started with globals, and then I threw my AST on globals. I had some arenas laying around in globals. I had some like stacks and stuff laying around in globals. And then some weekend I said, okay, I'm going to do threads. And then I just flipped them all to thread locals. And then some other weekend, I think I just said, I'm going to switch this over to like a parser struct. And then that way you could initialize multiple of them at the same time and have all the cool reentrant stuff. And the thing is, like, I sort of, I think there's a difference in perspective that goes on, which is that I sort of don't view the global itself isn't sort of, like the problem doesn't come from the global. Like in the same way that like, if I have a class, all of the fields of that class are accessible to everyone, every member function. Even though that's true, it's not like, nobody would look at that and go, yeah, but like that's like a global because it's like basically it's scoped globally. And the thing is, I actually sort of extend that to the global itself is the problem isn't actually like global scopes. It's the problem is oh, are your dependencies tangled? Do you know what changes are going on and what causes certain things to change? So for instance, I call this one function, some global got triggered. Whether that was a global or let's say a field, if my state changed in some way that I don't understand, I'm screwed. And then the problem is, oh, the global might be changed from somewhere else. Well, what if it's not? What if you do keep it like, function local? Then it's not the same problem. It's not a big deal in my opinion.
Right. That was.
I heard another.
In
Java, I heard another word for this is if you pass around pointers and they get alias all over the place, you get something called spooky
action at a distance.
Yeah, that was an interesting. I'm really thinking this is global. If you have aliases all over, it's like.
Yeah.
So what Yasser said, I think it makes sense. Like there's these two different or the different ways to use globals, and one of them where you tangle dependencies and you're not clear about where at which point you mutate data, like it becomes messy. But the problem is, I think that if you use globals, like what is your way of enforcing this? This is like the same thing about like memory unsafety. I think you can't argue that globals are fine because if you use them correctly, they're fine. I think that because I think this is like that's why
I would argue there's a lot of things in our society that are only fine if you use them correctly.
Yeah, so that's the thing. I actually would be okay with just saying I am writing my code correctly and then putting the sort of blame on myself. Some of that comes from the fact that I work as one person, but I have a bunch of soft constraints in my code base where I say like, oh, this is how the peepholes work. You have to guarantee forward progress when you do constant propagation.
Yeah.
or you have to guarantee that peepholes don't loop forever. It's like, I actually haven't proved that all my peepholes don't loop forever. I'm just like pretty sure that they don't. And
Right.
like actually proving it would be particularly difficult.
Sure.
You can
I mean,
assert for it relatively easily, but you're
Sure.
correct. Proving it, that's a bitch.
Yeah,
I mean,
exactly.
yes, of course. I mean, there will always be like things that where you have to like, you won't be able to like uphold some invariant through your interface in a certain way. You need to kind of rely on knowledge and stuff. But I think I would argue that like reducing the instances, like a number of things that you have to keep in mind or understand about the code base at all times, you should be kept to a minimum. And I guess I'm wondering also, what does this style of using globals buy you compared to passing things around in functions?
I'll show you. So I got
Could I say one quick thing, or do you really want to get into this?
well, it's gonna let me roll through here and we can go back and forth some more.
Can
So
you
like
increase the font a little bit?
yeah, okay, hang on.
And I'll quickly grab another cup of coffee.
There you go. How about now?
Yeah.
Okay, so private static final bit. This is my function local, except I can't do it, so it's a global. It's a bit set that I'm using in this walk. It's used here. I assert it's empty, and I clear it when I'm done. So at all other times, any other uses would blow. The walk says I visited, and if I've been there before, don't do it again. Otherwise, first time visit. Totally necessary when walking a graph to have a bit somewhere to
In Java.
avoid infinitely looping in cycles and exponential and yada yada. But and this is a generic walker visitor function. And the key point here is down in the walk where I go recursive on myself, I'm passing something along, and the implementation has to go, and the apply here has to do something interesting. And what I don't want the apply to have to do is pass the visit bit along to the next instance of walk. So I am trying hard to not have passing the in and out. So this particular version, I make it a leaf, but I have walkers that recursively go from one to the next without being a leaf apply. And they would have to pass the visit bits through. So in order to make the consumer of the walk guy not have to pass visit bits through, I don't want that argument visible to them.
But the key
And you can't just move
sorry for
that
interrupting.
line one down and put it in the definition of walk.
Yeah, because I would have to pick a new, okay, in that case, so I could do this. I could move this line down.
Mhm.
This one has the problem, I can't put a static here. So then I could do it this. Now, every time I call walk, I make a new bit set. And this goes straight to Cliff's, performance, whatever. This is all throwaway. The walk is only ever used exactly once
Yeah,
here.
that's a syntax error anyway in Java.
Right,
But-
but in
but
designing
the
a
way-
new language, basically what I want is the ability to just say static there.
Yeah, no. In many
And say, here's
languages
this
do
thing,
that.
it's totally scoped right here, but it's
Yeah.
also static, so only make one.
But
Yes.
I would say that it's not really that bad. First of all, it's a private, so it's a global, but only for the file, for the class. It's not the global for the program. That's really no problem. So you're dealing with the state only inside this class.
Let me write the Java code I want to write but never could, which would be this thing here. Now this visit's got the correct scope, and I want it to be static, and it does the obvious things it needs to do, and it's not a global, at least not by people who complain about globals. So this is a version of the global that I wanted to write and I couldn't. Had I been in some other language, I could. Here, I did the nearest approximation I could get out of Java.
It's a
what's the
global,
hurdle?
but the
In
name
AA,
is
you would
not
solve that
properly
by just
visible.
closing over it.
Yeah.
But yeah, so what's the problem moving into the argument position?
Well,
for
this
the
is
walk?
my point here is there are people even on, not to mention names, there are people even on our Discord that would complain because that has a global, even though it's clearly scoped just right, those two functions, the top level and then the recursive piece.
So the problem is how global is the global? Here
How
it's not
global is the global? And some people are bitching more or less.
It's not just that though. So you have an assert is empty, which is good. What you're saying is I shouldn't get here if someone else is already
Right.
shitting in this,
Right.
right? And then you have a clear at the end.
Yeah.
But what I'd argue is it would be reasonable, instead of that assert is empty, just say, take, if you will, and release. Like have an actual, hey, like I expect that no one else is using this and I need to take ownership of it. And then afterwards, I'm going to release it. In other words, you're designing explicitly like this will never be used on 2 threads at the same time. I guarantee it. And if so it just kind of closes that loophole. Now it's still a global, which means when you do use it on 2 threads, you're going to have to make some other change. But if you do use it on 2 threads, it's guaranteed that if it ever gets used at the same time, something like, it's not just assert in use, it's a cas, right? It's like I have to assert that I can cas from not in use to in use type thing.
Yeah, I could make it atomic here.
Right.
Yeah, I'm a big fan of languages that have a with statement.
With
this lock. As soon as the with block ends, then I'm going to give the lock back.
Well, not just that. What you really want is kind of a with, like all the code that executes under me. If it asks for this thing, it needs to get this thing for free, basically.
Right. If you try to access a thing behind a lock without the with statement, it should just be like, no.
There's some.
Yeah, and what I was saying is it's not about a lock. It's more that if I had 2 threads running, they'd have 2 different bit sets.
This would definitely bother me because is this supposed to be if you have only one instance of this class?
There's only, yes, this class this is a static. I can only, and it's not recursive. I can only call this function on the top level. It completes the walk and it comes back. Within a walk, I don't start another walk.
Because I write unit tests, and this would just interfere with the unit test because I would just have one instance, it would be done, and then the next instance would just be incorrect.
So we have the concept of thread locals. Is there a concept of thread statics?
Well,
that's what I do in C++.
Thread local is a static in that sense.
In C++,
wait, what does static mean in this context?
Yeah,
like
that there is only one of them, or in the case of thread local, it would be one of them per thread.
In C++ and Rust, I think static means.
You could do thread local and static at the same time, and then you just put those in a function or something.
In C, open up your static.
Levo, you're breaking up. Go back 10 seconds and say again.
In C, you can definitely write static __ thread int, and then that would be for that specific function for each thread.
Right. Okay. Just for yes. Okay. So you're scoping the namespace of the function, and it's also unique per thread.
Yeah, unique per in that function, unique per thread. Yeah,
that makes sense.
So I have a question. So Cliff, about this, like the code you just showed. What would be the downside of just passing a state object around everywhere?
Oops. Hang on. It's the consumers of the walk. Why did it change? Oh, I see what happened. Okay. The consumers of the walk have to pass the thing through. This particular walk, I should have grabbed a different one. This particular walk is the apply function here is only called at the leaf, but I have quite a few variations where the logic of the walk requires me the node make a decision about what gets walked after a particular node. So when you go into a node, and I call this a TikTok style. There's a common piece of the walk that everyone uses. There is a specific piece of the walk that a node uses. And if you're the specific part per node, you make a decision based on your local state, and then you again walk. But in order to again walk, you have to pass along something that you got passed. So you have this pass through that's carried into every version of the apply for every walker. To do this
what I'm asking is like, what is the problem with this?
It just bulks up the code. There's no problem except bulks up the code.
Okay, I mean, I think
this is why Levo has his thread local statics per function or whatever. Exactly, I want to hand something that every instance on this thread calling in and out of these functions has access to, but I don't want to pass it everywhere.
So you can just mark it. Go ahead.
So I mean, I just wanted to say that this is actually the gist of the issue, and maybe this is also like good to point out because I mean, I think you're reaching for this because you don't want your code to look ugly and verbose and have to pass around everything everywhere. And I think this is also like a weakness of you could say a weakness of languages that they like don't make this. This might be a good hint for language designers that you know, if you need to pass data around and you don't want to avoid statics and globals, like maybe make it easier to pass around the context object. Or
you can just
like
call it implicit. In Scala, you can mark it implicit and...
Yeah, I hate the Scala implicit because it just
context is the right word, though. What you want to do is infect the thread with a context so that anyone can very easily grab it from anywhere. And so, you know, for example, there are languages that reserve a register for their context. JVM does that for some of the JVM implementations, steal a register and use it for a context thing.
Thread local is that too. It's the GS segment register.
Right, but and so what I'm talking about though is where I can so basically it's recursive safe. So this code that Cliff's talking about here, if he did walk recursively, setting up, it's kind of like a try with resources almost, right? It's like I want to push what Levo was talking about. Like if anyone was already using it, push it, put the new state there under that name or whatever.
Right. No, I like the Levo's solution. That's an interesting one. There is a stacking notion. This walk is not recursive, doesn't need to be.
Right.
The toString walk wants to be recursive because when you're in the debugger calls toString constantly everywhere. And I might be debugging in the middle of a toString and I'm inside the debugger who's calling toString recursively. So I do make my toStrings recursive, and there are other places where it happens. So okay, so I guess I'll go back to say Adrian's point is this could use some language support, at least in Java, and some languages have this support, some don't. But I would use language support for this.
So earlier, Adrian was saying that like it's not a problem if people use it correctly. What I was going to say was, even though my global stacking solution is correct, Cliff never heard of it. No one knows what it is. It's going to be bizarre to everyone, and they're all going to complain. It doesn't matter if it's correct.
Well,
if people don't understand
we use it for the stack.
Yeah,
but if people don't understand it, they're going to complain about it, and I can't teach everyone how I write code.
No, but I disagree that they'll all complain. Some will complain. You just harden yourself to those folks and say, I don't care that they're going to complain.
Oh, I say that. It's just people get upset after I tell them I don't care.
So I think it would be fine as long as you confine to a boundary, a file, a component, or a functionality that others can rely on it, so they don't have to read it and understand it. So that would be fine if it's within some boundaries. So I don't have to
does this need language support versus just a developer culture? Like
both,
if there's
actually.
just a tradition of always passing the context object, no matter what function you call.
I mean, I agree with
like Scala lets you have anything
to be fair, that's what we sort of try to do.
You could imagine a language that had a single implicit that was named sys or in env. And it just always gets passed into every function. And if you explicitly pass in env, then you've overridden the environment you pass in. And if you don't explicitly pass in an env, it just takes yours.
So
Odin has a similar concept.
Odin has a support for that.
Yeah. I've been in projects where people passed in an explicit env or context everywhere. And then the answer became, it's a shared mutable state that everyone has access to. So everyone hacks it, and then you get the spooky action at distance problem because everyone has access to everything in the context.
So to my opinion, the context is not enough. So for the example of Odin, you have to know all the context it supports. So you have to know it beforehand. So there is no type support for that. To get in to really rely on it as a type. So you have to guess that this thing you are searching for is there.
I was pulling up code to show TikTok style with complicated decisions on how you went back and forth and why I would want to use globals instead of or
I'm fine with this
globals or whatever.
I'm fine with this because they are not really globals. I mean the globals.
Right.
That's really
They're managed. They were tighter than a standard.
They're scoped. Let's say they're scoped. Go. So.
But I'm scoping them, I'm gonna say manually without compiler support, but my intention is that they're scoped. Yeah. Yep.
Yeah. That's completely fine.
Yeah, it's also this is, I think I tried to explain this to Debiendu, but it was this is like a sort of senile sort of thing to do. And like
people are not gonna understand you. I know what you're trying to say.
Yeah, no, but it's a very like it's a very senile thing to say, like, oh, I'm gonna have like this function local static, and then I'll just like use it because I don't want to pass things around. And it's like a C programmer would do that. And if somebody in, let's say, I guess this sort of a corporate Java, I guess, would see that, they would not react nicely to it. And it's just a different sort of there's just a sort of different like culture, I guess. Like Java programmers and C programmers are just going to value different things, and one of those is probably going to be, I think, the
cost.
One of those is that C programmers never developed like a sense of like best practices because C was never unified enough, I guess.
I certainly get plenty of comments about best practices on C code when I was doing my C++ at Hotspot and Sun. There was a lot of screaming and yelling.
Oh, I imagine C had a lot of it sorry, C++ had a lot of it. Yeah.
I see. Okay. Yes, fair enough. Fair enough. It was also very funny that the people who were most passionate that you must have a coding style couldn't agree among themselves what that style was. So
I know,
you guys go in a room and fight it out. And they never came out of the room, so problem solved.
Yeah.
The people I know that are okay with no mallocs are all C programmers or have done C as well. So
actually, ironically enough, malloc is one of those cases of globals.
Yeah.
Like nobody minds that the heap is a global, actually.
Yeah, heap's all global.
Well, so the funny thing about it is that it's not I don't want any globals. It's that I don't trust myself with the globals. The runtime's allowed to have globals because whoever wrote the runtime is like, they're okay with writing globals.
They're okay.
But then
I mind.
I mean, some pointer knows where the stack is.
For what it's worth, I do mind malloc or new in C, and I think it is a bad practice to have a function called malloc behind your back instead of taking a pointer to pre-allocated space.
That's good.
Right,
actually.
but I also don't want to pass malloc into every single function that allocates.
But that's the point. You should not have every single function allocating. It should be hard, and it should be inconvenient, and it should be discouraged, and it should be friction for the programmer. That's exactly the point. Yes.
This is the difference between Java and cost of allocation.
Yeah.
It's free.
I mean, I have heard people talk about new should be a function that is passed into main. Yeah. And if you don't pass a function the new, then it doesn't new things.
Yeah.
I know that Zig, for instance, likes being very explicit about it. So you pass around allocators. You can make it global and just pass it around, but I doubt people consider that very good practice because the point is, I can be very explicit about these functions want allocation, these functions don't, because allocation can fail and stuff like that.
All right.
I don't think allocations can fail, but
No. Well, I mean, they could.
On Linux, they can't. As far as I know,
that depends on the Linux because that depends on whether or not you have overcommitting or not.
Yep, my strategy for a failed alloc is kill the whole process and start over.
Yeah,
yeah.
I usually just playing around not reaching levels. So just don't allocate a bunch of memory, and then that way you ideally don't run out.
Okay, next topic.
Yeah, leave us with.
I could just tell Matt. So when I said there's no, the user can't explicitly alloc in Bolin, what did you think, Matt? I bet you were just very confused. You're muted, by the way. Okay, never mind. He's probably not here.
No, just I'm muted. What do you mean by that?
Because when I first showed everyone in my language, I was saying that the user can't explicitly malloc. Like the compiler chooses when and where and how you malloc, or how the memory is managed. I don't know
I don't think
No,
it
it's
was just, I don't know if it was just for me, but I didn't fully hear your audio.
He's cutting in and out.
I didn't hear
I
that.
didn't forget it.
The question from the comment from Livo is that his code doesn't allocate. How do you feel about that?
I mean, sounds good. If you don't need to allocate, why would you allocate?
We're skeptical. The panel here is skeptical that you never need to allocate.
Yeah, I'm skeptical.
I'm skeptical too.
You really don't need to allocate technically. I mean, you start your program, you have 64 gigs of RAM, and then you divide it up.
Yeah.
So,
yeah.
right?
Other than that, you know every lifetime of your variable, everything beforehand, so you can execute your program without allocating.
Well, isn't that the Aleph or Epsilon garbage collector? It never recycles, and you run until you run out of memory, and then you crash without memory and die. And the answer is actually you grind pretty quick on a lot of things. You really need that lifetime management, or you can't do even trivial shit. 64 gigs does not go very far these days. All right, this is for Levo TikTok. See if I can go throw it up here. It's just a stupid design pattern. It's nothing terribly clever. So it's, oh wait, I'll screen share happens. It's I do something common for everybody, and then I do something specialized, and then I go back to the common, back to the specialized. So this is toString for my Hindley-Milner type variables. There's a toString. It just calls the top level stir guy who brings in a stir buffer. SB everywhere is a stir buffer. He needs 2 passes, one to get my dupes so I can print duplicates with a shortcut. And then he calls understir, which does the work. This is the tick flavor. Tick guy does a bunch of things, including deciding that you're a dupe, deciding that you're one of these Hindley-Milner does unification or you're unified in mid-progress, shortcuts for a couple of special things. Then he calls stir impl on the bottom. That's different per guy. The generic one that everyone gets, they don't do anything, prints your class name, an open paren, lists your arguments, and calls the tick flavored again on each of your arguments recursively. Since the tick handles recursion with visit bits, I don't have to deal with that in the talk version. So there's a dupe. The dupe counts as your visit bit, because if you're duplicated, you're going to be, if you're visited twice, it's only because you were a duplicate. A sample talk, and this varies by thing. So here is I'm a pointer type versus a struct type versus a function type versus a base, which is like ints and floats or stuff like that. He has some specialized print because he's a function pointer, including what your aliases are. And he makes some more special cases because there's a lot of common pointers I want to pretty print specially, like the nil pointer, or I'm a class, or I'm a primitive. In the default cases, I print a star because I'm a pointer, and the alias. So whatever it means to be an alias, I have a pointer to a person or a pointer to a whatever. And then I call the tick version again on the child of the one child of a pointer, which will be a struct. You always have a pointer to a struct. The struct will then print according to first the tick, and then the tick will go back to the struct's specialized talk version. So that's it. There's a common part of the recursion and a per subclass part of the recursion. That's what I mean by tick talk.
There's so little white space in your file. I'm surprised that there's white space around the ternaries.
You are so doomed. What are you going to do looking at my code with no white space? I could throw in more white space, but it wouldn't help me. So, okay, there it is. There are large chunky comments floating around, and there's generally spaces and comments around functions, but not always. All depends on scope. So for instance, a thing that I'll do commonly is like this. If some condition returns something short, and I'll put that on one line because it's just like a dumbass. If test return dump something short. So
my returns are often on the ifs as well.
I'm sorry? Your returns? Okay, well, there you go. So what out here would you expect?
No, it's just funny to see your code compared to everyone else's.
Oh, I see. I'm not the only guy who writes dense code. In fact, one of my inspirations was from Doug Lee, who writes code that's just as dense as I do.
If you weren't see it to make it a little denser, I see it have comparison against 0 and comparison against null.
Sorry, say you're
In
talking
that-
about my code or in general?
Yeah, in C you could make it a little denser. You had that line when you had comparison against 0 and you had comparison against null. You could just write if args, for example, instead
Oh,
of
yeah,
args.
totally. Yeah. This is Java. I can't just say if args. AA, I'm going to say if args.
What a terribly verbose language.
It is. I have to say
We should
shit
try
like
APL.
private void whatever, keyword galore. Fine. Anyone else want to stare at my code for dense? Yeah, here we go. This part's actually pretty dense. I'm gonna go back up to the top. There's some giant ass comment about what's going on here, followed by whatever. Here's your globals. That's a test thing that I should get rid of. Well, I now know I can get rid of it. Didn't know.
Oh no, you're using print line. That's also a global.
There you go. System.out is a global. You betcha. And then everything else gets in there. Comments. There's a lot of train wrecks in here where I tried things and didn't work, and I haven't yanked them all. So there's a lot of stuff in here that now could be yanked, but I don't know that it'd make it more or less dense. All right. Yeah, Adrian, your mic is good. It's Levo's mic today that's giving us trouble.
Yeah, that's what I meant.
Okay. APL is dense, and Aaron, your spelling is worse than mine. It's so sad. Yes, I did my 24 characters in-body simulation. I don't know, it was 24 characters. It was not very much code. You can get super dense in the APL world. And I don't know what to do about that. There is some point where it's too dense for me to read. And then I'll come back and add white space. But different people have their different levels of white space happiness.
Okay, a quick check. Oh, go ahead.
I do wonder the degree to which editors can help with that, though. So, like, if you want to have a really dense single character thing, if you have a structure that says, okay, well, on the line before this was initialized, I put a / comment that says this is a doc comment. Maybe it's just as easy to have an IDE that lets you use a single variable character, but if you mouse over it, shows you, oh, here's the doc comment on that variable. Like, one of the answers to I'm being very dense because I assume you have a lot of context in your head is have a way for you to get the context into your head.
I'm usually very dense because it helps me hold more context because I'm visual and I stare at the context.
I actually think this visual thing that you mentioned quite a few times already. I saw that also in some other compiler projects and stuff. Like, for instance, TCC, this code, it's also quite dense, especially like looking at the code generation stuff. But actually, there's lots of, I guess, I don't know, structural. There's a rhythm to the code, kind of, and when it becomes dense, you can kind of see it, like and understand it. And also, I think once you've been writing a compiler before, if you've never written a compiler before, this code will look very, very weird. But if you've done it once and like at least written some lowering passes and stuff, like suddenly things will become much better, and the terseness is a lot less of an issue. I think like it depends a lot on what, like the kind of project. And I think for compilers and so sometimes this terseness, I really appreciate it, actually. So because you just see like certain functions have like this rhythm to it, I guess, I don't know, or this a certain style of like, yeah, if blocks and control flow and stuff that you just recognize again.
Well, I do a lot of
run into that with I run into that with what's it called? Half of the job of like understanding some other compiler isn't even like looking at the code. The code is only going to tell you like what they currently have done. Like, you want to understand what they're thinking, sort of. And so a lot of that is going to be like, oh, there's like certain constraints that are like the soft constraints that I mentioned earlier. It's like, oh, these soft constraints mean that the p-poles are going to run in linear time. These soft constraints mean that we have constant propagation in this way, and things like that. And those are like not necessarily written in the code, but they're like you can sort of see their shape once you understand what the person was trying to go for. And so it stops mattering exactly how they name variables. Like, I don't really like, in a sense, when Cliff named this variable like W visit, it doesn't really matter what W visit means. It probably means walk visit, like as in like the visited set for the walking, but the W visit actually doesn't mean anything. It's just like it is the visited set. It is some visited set for some context, and like that's the shape I'm looking for rather than like the name telling me anything.
But if you haven't seen the code, the names help you infer the context. So what we need is something walk visit or walk something. So Cliff can abbreviate them, and a flag that will expand the names to something more readable.
So common in compilers or graph walks. That's a common meme across all compilers because people have control flow graphs, they have whatever. Okay, graph walking has particular style to it. There is some kind of way to stop the revisit on a duplicate visit, or you go exponential or infinite really quick. So you have a visit bit that has to be test and set. You have a thing to do, and you have a go check my children in whatever direction you're walking the graph in. You may have a pre, post, mid thing to do, but you have these common patterns in graph walks. So when you've never seen a graph walk before, I can well imagine it looks weird. When you've seen 1,000 of them over your life, they all have this same pattern, and in a glance, oh, it's just another graph walk. And you can pick out the parts. Here's where he's walking the kids. Here's where he's checking the visit bit. Here's where he's doing his apply function, doing something. And so I think, yeah, there is a style to that kind of coding that once you've picked up, it's easy. And if you haven't picked it up, I think that's part of your learning curve. Time to learn what a graph walk looks like.
How often do you find that you have a comment that simply points to an external resource? Here is a link to a wiki page of what graph walk style is.
In uncommon, but they're typically put in important places. I have them. They say shit like, hey, I went to the wiki for ordering lattice ordering, and I have a lattice that has the following properties that have deep theoretical meaning, and I'm not going to explain them in line. Go to the wiki page. Right? So that happens. C2's got something for like, here is integer division by a known constant denominator, such as divide by 10, 100, or 1,000, because you're doing printf. And you're taking a binary bit and you're going to turn it into an ASCII string. Well, you have to divide by 10. Okay, how do you divide by constant? Well, there's this cool paper from the 70s or 80s or whatever, and I got a link to it. And go read the paper on it. Here's the fucking code that comes out of the paper. It's dense, it's tricky, it's carefully off by one here and there for all your, how you do all your math. Don't bother to understand the code, go read the paper.
I think there's maybe like 5 places where I like reference a paper, and then I started writing a glossary in my code base.
Yeah.
Where I just say like, I just have like a bunch of acronyms that I put down because I'm like, okay, it'll make it easier if somebody can at least see the acronyms that I use, because I will use those everywhere and I won't link to anything. And so now there's a glossary. And then I'll sometimes reference papers. I think the main ones I'll reference are the dominance paper that I use, which is the Keith Cooper one.
I've put links to dominance in.
Yeah. And there's probably a few others, but I can't remember them right now.
The primary way I know all these terms is I just looked over the optimizations that GCC and LLVM do, but I don't actually remember what most of them mean when you guys talk about it.
So I threw into the chat. Here's what I grepped for HTTP in my AA, and I got 5 hits, 2 of which are just Creative Commons, and then Bertle for a hash function. And then wiki order. Oh, twice for the wiki order. So not too many. There's like 2 or 3 real things there, but it happens. I don't have don't have the magic divide function. I don't have dominators, but when I did dominators in C2, I certainly threw in the link. And I think Debiendo put in a dominator link in simple. So they happen.
Oh, yeah. Yeah, my implementation of GCM has, or Global Code Motion has a link to your paper. Yeah. And then I've also got paper, or like not links to papers, but links to docs, things about futexes, things about the C-spec, CRC, L files.
Okay. The C-spec is because you're doing a C compiler?
Yep.
Yeah, okay.
There's a bunch of random places where I say, like, this is how this thing works because C is weird.
Because C is weird. Yeah, exactly. Go read the spec. Yes. Okay, fine. Same for Java bytecodes. hey, this is fucking weird. What? And then, oh, read the spec. You know, mod and div. There's mod and div, rem, whatever, bytecodes. They do a particular flavor. Go read the spec.
Yep.
I think I might need more weird C++ tricks. I'm trying.
Everyone
trying
needs
to-
more weird tricks.
That's a new sentence. People shouldn't be saying that sentence though.
Yeah, because I'm putting together like it's not like a joke library, but it's just a library for personal projects, and I have I have a way of figuring out if a pointer is a pointer or an array, and another way to clean up things without using a unique pointer. But I kind of think like if I knew more tricks, I would be able to do more things. And I have no problem with getting the line and I have no problem writing the asserts without using macros. So
Lebo,
that's like another trick I figured out.
I think the biggest, bestest, fastest way to get a new trick is force yourself to go write in an unrelated language for a while, just so you pick up how other people view the world, or the world could be viewed. Go get standard ML, go write Prolog, do weird, funny languages, go write something fun and stupid, take a month to code enough that you can code in anger, and you will learn a whole nother way to think about the world, and that will be way more productive to your long-term.
Well, this specific idea was to write a C++ header, so I could just not use the standard library. But I'll show you guys that like
Right. No,
next
that's
week
an
when it's
interesting
ready.
one, not using standard library, but it gets you deep into like assembly language and calling conventions and how to go do OS.
Oh, I done that. I done that once before.
Right. Well, I'm saying if you instead looked at how Prolog deals with the world, you'd have a wholly different view of what you can and can't do and how you might look at coding projects.
I actually did look at that for like a couple of days. There's a book called 7 Languages in 7 Weeks or 7 Days.
Oh,
I think it was 7 weeks.
Yeah, right.
That was a fantastic book.
I mean, I had
I
this
read
class,
it.
but yeah. But link 7 languages in 7 days. Let's get a link here.
Yeah, give me.
Go ahead, I will find it.
Okay. Yeah, I'm already at the Google, but somebody else can do it. There we go. 7 languages in 7 weeks, sponsored by Amazon, a practical guide to programming learning. Maybe I don't need the Amazon buy me now link. I'll get this link, but somebody can find a better link. I'm gonna throw a link in, and Theodore, you can yank mine, put yours in if you like it better. I have a dumb, I can't find it.
I put one, but
You already did it. All right, done.
I don't know if it's fine.
Yeah, oh, I think I got that one. Yep, fine.
It feels like a brand new book, but it's 14 years old.
Well, language has been around a while, and variations, coming from the old school world, old computer chips were very different from each other, and old languages are all very different from each other. People kind of honed in on a certain style of common. We all love these things. We all hate these things. Everything looks like fucking C. But yeah, fine.
I'm a little surprised that people say my code looks like Go and not C. Just because everyone always says something looks like C.
Something about your keywords make me trigger on Go as well. I don't know. I haven't looked enough Bolin code, but yeah, I'm with you on that.
Well, I think it's because I don't have pointers with stars and stuff like that.
Oh, maybe. And you don't look functional. So then
Yeah.
now maybe Go. But Java has no stars for pointers. But you don't look Java-ish either. Why? Why are you not Java-ish or Go-ish versus Java-ish?
No, that's a question.
Well, when it's out, we will try to see.
Sorry?
When the language is out, we will try it and see.
And see. Ah, gotcha.
It's been out for 2 years.
Well, we need some more code bases. Somebody's not writing lots and then showing they're written.
Yeah. Okay.
Lack of allocation kind of scares me.
Changing topics, maybe about we're maybe returning to topics about modules. How people prefer to organize code. Let's see. Files, functions, inheritance, and classes, mixing, compositions. So which one?
Count directories as part of the files.
Okay, five. Okay, let's put it in the files category.
Okay.
All my files are 2 to 5,000 lines.
There you go.
So how do you
I
split,
don't
split
separate it.
functionality? How
This
do
is
you
a number
split
I can get
functionality?
easily.
Eh,
So I'm now curious.
How I split them?
How
It's
do you
based on-
split functionality inside it? The functions, classes, compositions? What?
Never really thought about it because
Yeah.
essentially I go by headers. If something has a header,
Wow, you're breaking up again.
You're really choppy. Can
Yeah,
you
you're really breaking up.
jump a
never
few
mind.
sentences?
Yeah. Well, I can tell you that the size of my files is probably averaging around 200 lines. There are some bigger ones, but there's not, and they usually have a reason for being bigger. Most of them are relatively small.
My preference is actually pretty closely aligned to what OCaml does. I actually think they're hitting on so many spots that I think are pretty nice. So like what I like for my language is basically modules as a grouping of fields and definitions. And definitions are functions, constant values, or other modules. And fields are, well, like, yeah, so, I don't know. And then a file itself can also be a module. So everything is like you get rid of one level of nesting. I think I like that a lot.
Do you fall in the Java? So each file has to be inside a correct directory, or?
No, there's a syntax for declaring a module, but the thing is, like, it moves the nesting like depth, like indentation by one, which is a bit annoying. So there's also the option of having a field be a module, like it, yeah.
A field be a module?
A file, sorry, a file.
File be yeah, okay. So you can just say this whole file is a module, don't indent, just take it as a module.
Yes.
And otherwise,
so everything you name it, not the file, but you name it inside the file. What the name will be, the module will be, correct?
The name of the module is the file, name of the file.
Okay, so
but is there some indication in the file that it is a whole file module?
I need to think about this.
Okay,
I'm
so
not sure.
Somebody else, some other program from the outside looking at a big pile of files wants to discover the modules.
Yes. So it is an indication because every file is technically a module because, as I said, modules are a grouping of fields and definitions and such. So
every file is its own module.
Yes.
And then you can group other modules together to make bigger modules.
Yes.
And is it mandatory? Is it mandatory that one file equals one module? Can you define multiple modules inside a single file?
Yes, you can define multiple modules in a single file.
Using a keyword, so you have a keyword for a module.
Yeah, right. Like yes. Like kind of like how you declare a struct.
But by default, the file name is the name of the module. You can import it in your program.
Yes. So modules take also like care of namespacing and the path basically.
Yeah.
That's kind of like how I do mine, actually.
I kind of like that one too. I watched Ecstasy where the file name and the module name can vary, and that kind of sucks, actually. It just adds a layer of confusion. I think they should be the same, yeah.
There's one wrinkle to this, and that is that if I want to have generic modules, I need to add additional syntax for this special case. So because, for instance, if I have a generic struct or something, I can in the file I can say struct, and then I use some kind of parentheses, and then the type parameter, and then I define it.
Yeah.
The thing is, if I have, basically, if my
go ahead.
Sorry.
You finish.
Yeah. So, but the problem is, what if my file is the module that I want to make generic? Then where do I define the type parameters? I can't put them in the file name, right? So I need to like add maybe special syntax and say like at this top of the file I declare a few type parameters, and that's a bit confusing, I think, for the user.
Or you can just name the module like the file and add the type parameters there. So it's a file.
Not in the module, in the file name. Like I want to write a generic hash map. It's got keys and values as generic types. The file name is called hash map, not hash map angle bracket.
No,
right.
And inside the file, you just specify the generic. You say module hash map, and it's the same name as the file name, but you add the type.
And then you add the parameter. Yeah, that's what I heard you say. Yeah. Okay. Fine.
But the answer could be very project specific. So I've seen the YouTube Python code base when I was working at Google, and they were very strict about every file is exactly one class, and here's all these rules for breaking things up. That ended up being incredibly important for their automated refactoring tools that they were using over a very large code base.
Right.
I've also worked in Python at a 10-person startup where everything was super flat and we had one folder that was basically project. And essentially all of our modules were one file in the project folder, and they imported each other just with the names that were next to each other, which saved us from a whole bunch of bureaucracy of how to organize the code of the project.
Right.
Yeah. It's an
So the right
end-to-end means.
answer for what YouTube needed and the right answer for what the 10-person startup needed were totally different, even though they were both Python projects.
Yeah.
Like
Yeah.
saying that the language should pick how you structure modules and code may not be the right level of abstraction to make that choice at.
But you need a good abstraction to support both, so you to not get into your way when you're starting, but an easy way to split them when the scale begins to be a problem.
By the way, I don't want to claim. Oh, sorry.
Aaron, which style did you enjoy more?
I mean, I enjoyed the flat style more because I had a lot more say over how things was organized. It's more convenient to be a 10th of the opinions in the room than a 1,000th of the opinions in the room.
So, by the way, Aaron, what you mentioned, I don't like saying things like skill issue and stuff, but I do have a feeling sometimes that for large files, like a lot of times people or engineers are struggling maybe too often because they are not comfortable with their editor or their editing environment. Like, you know, if you have lots of functions and they're reasonably sized in a large 10K line of code file, I mean, most reasonable editors will have a way of like a symbol picker or a function picker or go to definitions, and you can have a jump list or something like that. Even simpler, non-sophisticated editors should have like very good navigation functionality, and I rarely see people use them to their full potential, or not even close to the full potential. So I sometimes have a feeling that engineers who figured out how to quickly navigate a single file are much more comfortable with keeping the file long.
I use symbol lookup all the time. Very handy.
Right. And then your file can get big and you care less. Yeah.
It tended to be less the editors getting confused than the diffing tools getting confused.
All right. Okay. Yeah.
Yeah.
That you have some diff tool and it's like, if it's two different files, then it just like takes both files.
Well, I would say that if I move code around in the big file from here to there, I'm doing a little reorganization, I routinely get differs get totally freaking confused. It's been deleted, it's been added. No, it's moved. Why are you confused?
This is a big pet peeve. My main, like at work, we're using GitLab, and occasionally I have to review a merge request that moves code, like 2,000 lines of code somewhere, maybe into different files. And the fact that like this code review tool can't understand it is so rough. I mean, basically I have to.
Did he edit it while he moved it? He changed a few lines out of the 1,000 that got moved. Can you tell? Fuck.
Yeah.
So the other one that's fun is if I move a big function, or if I swap two functions and they're both in Go and they both contain the exact line, if not error, return error.
Yes.
If error, not null, return error.
Yes.
And suddenly it thinks, oh, this isn't a block that moved. I just need to transform each block into the other block by taking half of the lines and leaving half of the lines. And
I've seen that too. Yep.
I feel like Go is more subject to that than most languages, but it can happen anywhere.
I've seen it happen many times in Rust as well, for sure. Especially for control flow statements like match statements and stuff. They just have the similar structure, and then this happens.
Right. If every class is in its own file, that just is less likely to happen.
One thing I did was
let Adrian finish.
I did found one way eventually to review like these large code motions, and that is to just have two of them side by side, and then like jump with a symbol picker through the functions, and like then tab between like it's basically switch the buffer between the two versions and look if I see any symbols change. So yeah, basically
the eyeball differ.
Yes. So this it's super rudimentary, but yeah, I don't know.
But why don't you use something like diff so to show you the difference between
chunk here and it went over to another file at another place or another file.
Okay. So in this case, in this case, I resort to sorting them first in order, and then kdiff or something. Sort the file, sort the file, and then it will be easier to spot the differences.
Okay, there it is. Okay, then maybe I'm the one who has skill issues. So I'll try that out.
So back in the Azul days, we had a point where we had to prove that the code we were writing was all extended from the open source, and we had access to the paid for Sun Oracle code, so that we hadn't picked any code up from the Oracle side unless it was already in the open source side. So we had three sources. We had our stuff we wrote, open source, the closed source, and we wanted to do this triple diff where over the entire hotspot source code base, so I don't know, fucking 100,000 lines and 1,000 files, whatever it is, you wanted to, start with this, or start with this, subtract this, and add this, or whatever, and then look and see if you didn't pick up anything. And my go-to strategy was exactly, I sorted everybody, and then I ran a giant set difference, and it was shockingly good.
Yeah. That's the issue when I run into comparing JSONs. The order of the fields is not guaranteed, so you first sort them and then you see look for the differences.
I mean, I was looking at miles of C code. I would have thought sorting would have made a disaster. You threw out all the blank lines, and you threw out.
It's shockingly good for shockingly good. Yeah.
Fine. Okay.
That's an interesting solution. Is there like an easy way to sort the JSON? Do you use JQ to do that?
JQ, JQ --sort, and the diff. We use the command for the Linux diff, and I save them to different files to use them, and just use JQ and diff them.
Wow. All right.
One thing I wanted to do, but I don't know when I can implement it, is have some kind of way to say this is like a refactoring mode, and all the changes are like recorded. So like you can do a rename, you can move the entire block of a function, but not modify it, and then whatever else.
Hand that info to the differ. How do you tell the differ I moved this chunk from here to here?
I wasn't planning to do anything with the differ. I was just planning some kind of way to record those changes. So when you want to do some kind of like pull request or hand it off to somebody, they can replay your changes to make sure like you didn't sneak in a line, and then have that kind of supported in my editor. But I'm not sure if it's going to be complicated or not.
You get to
because every language is
like I'm hacking code and I undo and I rehack and I undo and I rehack and I move code and I hack and hack.
Well, that's why you can't edit it. It would just be moving function blocks. But the problem is, if you move a function block from one method, one class to another, you're really changing the behavior. So it has to understand that. And there's multiple languages, so I don't know if I could do that, but it was just something I was thinking of.
Yeah, no, that makes sense.
But I also don't know how handy it is. Like maybe people just don't care, and they'll
if the tooling would accept the series of diffs that you did and hand it to a differ tool, I claim we could get much higher quality diffs. The whole problem with pointing out here was, I moved a chunk. The chunks had something in common. Suddenly he breaks it up into multiple parts and keeps the common pieces between them or whatever. And just like, it's stupid. No, I took these two chunks and swapped them. Leave me alone. Or why can't the differ know that? Well, differ is trying to reverse engineer it. The editor knew it at some time that you swap those blocks. It'd be nice if you could pass that forward to a differ and have a differ take advantage of it. Yeah.
It would be more like it'll specify what LSP you're using, and then you're saying this LSP the user wants to use this LSP to rename this function, like this variable or this function, to something else. It wants to look up this function symbol and then move it elsewhere, and like provide that kind of information. So there would be no diffing, but it will be heavily dependent on LSPs. But it was just a thought.
You put those in the doc, yeah, okay. Because the different tools might do something better. I have certainly fallen over these diffing issues many times. Stupid diffs that make no sense on diffs.
Oh,
Maybe
what
worth,
diff?
if you are using the Git, it may be worth playing with the diff algorithms. Some of them are actually pretty good in terms of reducing the noise. Posted some links. If someone wants to play with this.
GitHub for Windows, I can pick a different diffing. I bet I can. But that's one of my options is go name.
And definitely change the merge config style, because the default one sucks and it's only kept for backward compatibility. So if you are using the default, you are missing out.
I'm on GitHub for Windows or GitHub.
Or just Git.
Git, yeah, okay. Yeah, I have to look. I have a unified or split and hide white space, and but I want something. I don't know what the other guys do, but I know I can go change what tool you use for diffing.
If I want to support diffing in my editor, which one should it be based on?
Oh, geez. I mean, Emacs has a bazillion configurable differs, and you can grab third-party differs and all kinds of stuff.
Yeah, but the patch notation or the format of the patch, I don't know.
I mean, I'm using a Git add-on to Emacs, and it does patch diffing style, and I can go sort my patches and in and out and move them around and whatever.
So I was thinking I should just look at what Git does and the diff patch tools on Linux, but I don't know what else. They could even be the same thing.
I think Matt just said Git has a default and there are better things, and grab from the betters. I would take Matt's list here and go stare and see if there's an obvious this is the current best practices of grabbing a diff.
Well, I thought that was producing it like a patch file, not. Or,
No,
I was looking to it.
Go fucking stare at the code. It's not. I don't want to patch. I want to fucking stare at the code. See what the diff is. I don't know. All right. What else? I think we're winding down. I'm ready to wind it down.
Yeah, I guess project updates was I started. I got back to working on my new IR builder, which basically is just the one that's supposed to like do the whole building SSA on the fly and such. Which for the C stuff, I don't do as many optimizations on the fly just because I build addresses and stack slots and such for the variables, so they don't get like fun data flow stuff, which is boring. But the purpose of doing the fancy SSA construction is actually for a different kind of variable, the memory. So like I can split memory and stuff like that and have the phi's inserted correctly. And then that's still valuable. And then if you wanted to do with scalars, you could pull it off if your language actually doesn't have every variable have an address. And then, yeah, so I'm currently working through using that now. And then I'm going to use that to implement restrict semantics so I can have that in place. Because I've run into a bunch of places where it's funny because I remember reading through and I was like studying before I ever like did C of Node stuff. I was like studying how LLVM implemented restrict, and so they had this whole annotation system around like marking where lexical scopes were so that memory effects could know like am I in this scope or not. But the like whole notion of splitting and joining and like the splitting and merging of memory like solves this entire problem really easily. It's just there is these declarations have their own memory stream, these have their own memory stream, and they don't interfere with each other.
Yep.
And then people can just think of it as dependence, and they can just say like, oh, I can fold this thing that way. Or if you have like bigger optimizations like vectorization, the vectorization doesn't see I'm straddled between a bunch of like interfering like memory effects. It's more like I see an array, like I see an array store, I see the next array store. Those don't alias. I'll run like 4 of these together. I see a bunch of loads over there. I can run those all like, in parallel because none of them interfere with each other.
The splitting doesn't get fragmented and give you a gazillion memory nodes?
I probably not. So in the cases that I'm dealing with for restrict, you'd basically have if you have a scope that's got restricted declarations, what you do is you'd split before then, and then you join at the end, and you'd basically say that each restrict declaration, so the C semantics for it are basically anytime that you do any accesses based on one of these pointers, it will effectively will not alias with anything else that has any memory effects that is not based off of that same. Like, let's say we had a pointer A or something. It's not going to interfere with any other pointer effects that are not based on A explicitly.
This is the equivalence class aliasing based on some particular equivalence class definition you got there. I don't know, right?
Yeah, and exactly. And each declaration gets their own equivalence class, and then just like a leftover, like everything else, kind of a blob.
Yeah.
And then
certainly the C2 Java version never looked like it could have exploded, and it never really did.
Yeah, I'd imagine it won't. A few reasons. One of them is that people just don't use restrict enough. And the places where they do use it, it's usually like you open up a scope and you have like a function and you say the parameters are restrict or something, and so you split and then you join, and it's relatively trivial. If you ever have like splits and joins like next to each other, they might like get coalesced, I'd assume. You could say like
messing around with that in AA at some point. I haven't
Yeah.
done much with it. It looks good. The C2 version just knew that everything was broken out by fields according to the Java class hierarchy, and that just came for free out of the typing. And then if you grabbed a split version, I didn't have to actually split it everywhere. I would just assume it was joined, except if I took one slice, I got the one split, and then all the rest were the whatever left over. So individual uses of individual fields would get a edge representing their split, but that never caused any aliasing with anyone else. And I didn't have to have a butt ton of edges representing unused alias splits that were known and visible, but never used. Those edges never showed up. So it never actually produced a ton of edges or nodes in the graph either. So it was pretty good. And I guess restrict gets you pretty close to the same thing.
Yep. The nice thing is that you can do it it can be done more accurately than the like type-based stuff. So like the type-based stuff is super nice because it's sort of overarching. Everyone sees, oh, this byte doesn't interfere with this integer and stuff like that, or this array doesn't interfere with that one. Yeah. And then what the restrict gives you the ability to say is like, this specific array doesn't interfere with this specific array, even if they're the same size.
Right.
Or like the same type. Yeah.
No, the type-based thing kind of falls down on arrays. So I move to variations where I do alias checking or range checking on the arrays. Like these two arrays are different, but I have to put a runtime test in.
I've seen LLVM do some of that kind of stuff, and it's one of those things that's like definitely a problem better suited for JITs because so the funny case is that so LLVM will call it loop versioning, and then basically they'll make a versional loop that's like the super fast one, and it'll do all of the alias checks up front, and then just say this is the fast path, and then they'll say like this is the slow path. But if you're on ahead of time compilation, you always have to compile the slow path, even if you've never hit it. And this is one of the places where JITs actually perform really nicely because JITs don't have to compile cases you haven't ever hit. They can just say, I'll defer to the interpreter and I'll just fail that way. And so you don't compile as many of those cases, which means that you're able to compile a lot more fast paths with your cost model changes basically.
Yeah. Okay, fine. Yep. Right.
You can say, I'll just tank the hit if it's like the slow path, and then it'll adapt around the slow path if the slow path is actually really common. But if the slow path is just never hit, then your cost model is like, I can just compile fast paths and just hope for the best. If I fail once and then it like adapts, that's fine.
I have seen. Go ahead, Arjun.
Yeah, when you say cost model changes, do you mean is it just about compile time? Like, if we don't care about compile time, why not do the same
code volume? You get
I'd imagine it'd bite you on like iCache if you basically like let's imagine we did it aggressively. We always compiled in the fast paths. You'd have a SIMD version of a bunch of random functions, sure, but like maybe half of those are actually used, maybe half of those are not, and now you've got a bunch of like sort of dead code that's just eating up your iCache, and also your compile times and stuff like that. You could probably split it up if you knew it was like uncommon, but you also, because you don't have any like profiling information, you actually don't know if it's the slow paths are actually that slow. you just know that they're the worst, or actually it's not slow and fast path in the sense of like this one is like run less or run more. It's more like this one would be worse to run in, but if you have to run in it, you're gonna have to. And so like let's say the array is always alias, you'd run in the slow path, and if you, let's say, optimized around, oh, the slow path is unlikely, it's like, well, you don't know that. And so there's a bunch of these questions that JITs can kind of clear up, I guess.
Yeah, you don't know that the aliasing path is hot or cold.
Yeah.
There's a no alias version and an alias version. Which one's hot?
Of course, from the language point of view, the answer is to let the programmers say it. In C code, often used by HPC programmers, you will have annotations like pragma simd, and then the compiler only ever emits the fast path, and the slow path would be undefined behavior. So that's one way out.
Yeah, MSCC has some like independent, like I can't remember what they called it. I think it was like invdep, which was like
invdep, ignore vector dependencies. Yeah.
Yeah, exactly. Yeah, it'll just say, I swear that these things aren't going to interfere, so you can SIMD them.
Wow.
You can also assert have built-in trap if the number of iterations is not divisible by 256, for example.
Oh, really?
That's also going to remove the runtime checks.
But that one's not too hard because you just have a catch-up loop at the end that just picks the odd iterations out.
Oh, that actually reminds me. The other reason why the cost model changes is because if you do blow up on like loop versioning stuff, it might not be one constraint you're trying to prove. It might not be, is it aliasing or is it not? It might be, there's 4 arrays being accessed and 3 of them alias and one of them doesn't alias. And you might have a version that works best for that. And so what LLVM will do is usually say, at least the last time I tried it, it basically just says, try to like figure out what is the best case out of, I think they have a loop version limit. I don't remember what the loop version limit is, but it's just to avoid the code blowing up, basically.
Right.
And it'll say, we're only going to do this many dynamic checks.
Right. You get an exponential overlap of variations.
Yeah.
Yeah.
I really want to write SIMD optimizations, but I can't. I never seen a compiler do a good job with those, and I think like the only time I actually seen
the bar is really low. You'll be easy to beat. Easy for you to beat it.
But the only like kind of user code I know that would optimize into SIMD easily would be if it's like checking an array, how many nulls, nulls or new lines it has. Like I don't know what else a user might want to SIMD.
Yeah. I mean, that was the SWAR stuff for that 1 billion row challenge, but there are a lot of uses for SIMD ops.
Yep.
Although you could go after the Bolin version of the billion row challenge, followed by get your SIMD ops on all those evil hunting for characters in a giant ass array.
Just make sure you get your loop unrolling first.
Yeah. Yeah, and if you want to be competitive, you got to be able to parallel as well.
Yeah, I gotta do threadings, but I also gotta finish that IDE first because if I knew how annoying LSPs would be, I would have just stuck to the debugger because I thought like LSPs is gonna be easy enough, but they are. It's just they're not very good.
They're all right. Let's walk away from LSPs at the moment and
it feels like I have to write everyone's code for them because they're so bad.
Yep.
Like I wrote an LSP better than what Clang gives me. Like what the hell?
You know what? At some point in your life, you'll make your choices about where you spend your time differently, and you'll just let it ride.
Well, it would be nice if I could hire someone to help me write the stuff.
Yeah, in order to be able to hire somebody, you have to make money. In order to make money, you have to get your head around the notion of making money and not coding. I spent much of my life coding and not making money, and you have enough money, you can go do what you want, but until you get there, you got to kind of go make the money thing.
I heard if you have a good prototype and no one else comes close to the prototype, then you can get some funding, but apparently that never happened.
I haven't got a good prototype, so I don't know.
Yeah, I have a good prototype for my language, but
well, it's good only if other people say it's good. So you have to not say it's good. You have to have somebody else come and say, "Oh, Bolin's the best thing ever," and then I don't know what the story on that one is.
I know a lot of people willing to pay for languages, but no one willing to pay what it costs a developer to write one.
Oh no, of course not. Yes. No. The most I've seen people make money out of new languages is like Julia. You get into government contracting, and the language is just sort of a thing to lock you into a market or lock the government into your style or whatever. It's not a, it looks cool. It got some government geek happy, but you're really a consulting firm.
I mean,
Cliff,
the thing is like, just to be fair, I think this is not often brought up. The people who use your language, the amount of effort they put into writing libraries and stuff, this is something you will never be able to repay. This is like thousands and millions of developers spending all their like not always hard work, or not a good work necessarily, but spending their time. Like there is obviously like if you have a decent language and if you give something good to the community, you get massive payback. So I think this is often left out in these discussions about economics of programming language design. Like if you want to make use of the network effect, then you do get lots of stuff back. So
but you don't get any money because they ain't got any money to give you. They're giving you their time.
Right, but that's very valuable, right?
It is valuable, no doubt about it.
I mean, I picture even giant organizations like Google. Google gives huge amounts of developer time to the Python community and like $1 million a year. It's like, how much do you make off YouTube that's entirely based on Python?
Oh God, yes. I didn't know YouTube was entirely based on Python. Wow.
So the heart of the algorithms is a bunch of C++ code. They're not doing transcoding in Python.
Well, it's the normal Python. It's just C++ wrapped around Python.
I thought YouTube was based on FFmpeg.
Yeah,
I highly doubt that.
But
I'm
the
pretty sure
vast
they're
majority of the
building
lines of code that make YouTube are Python.
I'm very certain that YouTube and Google have built lots of custom silicon solutions for transcoding. I highly doubt they would use FFmpeg. That would be very surprising.
Oh, I wouldn't be surprised if they started somewhere there, but yeah.
Sure.
I can imagine.
So it is less surprising than you think because there's a bunch of devices that do very bizarre, non-standard things with MPEG-4. So they've got a bunch of queues that are like, here's the one that decodes exactly how iPhone creates the file and is shaving cycles off where it knows it can skip steps because it knows it came from an iPhone. And it's got decoders that are like, this is the exact spec following decoder. And then it's got a queue that's like, and here's the things that all of our super optimized fast paths failed to convert. Can FFmpeg do it? Oh, look, it can actually get a bunch of these things.
Interesting. Yeah, okay.
The transcoding pipeline is more complexity than you'd expect.
Right. I believe it. No, I believe it.
But it's because, iPhone does things in particular ways. So if you can make a special version of your transcoder that is specifically designed for that exact layout of an MPEG, you can save a lot of money.
Yeah, save some money there. All right. I'm going to declare victory here. I have things to do. So it's
word of advice, Levo, don't rewrite FFmpeg.
Word of advice, Levo, focus on bowling. Drop everything.
3 days max.
No, not 3 days. 3 weeks, 3 years. No, get to bowling. Get to bowling.
Stop. I want to see memory management come out of Bolin, and your thread local stacked variables sound interesting. I'd love to see that one in action.
But Theodore, how is it possible? How is it possible to write a compiler without FFmpeg? I mean, explain.
It's impossible, yeah, but we'll skip that.
Remember that at some point you will need packages from the network, and at this point it's reasonable to rewrite curl.
Yes.
We would leave that for the optimized version of Bolin. So Levo get to Bolin.
That's the obvious really need to be said.
Let's not beat on Levo Day anymore. It's good that you're taking it in the spirit it's being delivered, but yes, it's time. Next week we can all beat on.
Wait, I just realized I'm my no standard header header.
Yes, exactly. You resemble those remarks that were handed out. All right, bye.